are the ones where you had to get the common base. Look, start checking. I want you to check your answers there. They're all there. These are the problems you had to get the right base. And you got to show me what you're doing. When you write it with the common base, you got to write it on the paper. Now, some of these came out pretty simple, but you had 11 to 22. Then you had, on the second swipe, you had 712 and 714, some problems, and 715 too. But every one of these is problems where you had to get a common base, then power to a power, multiply the exponents, and then you just solve what's left. Guess what I needed. Yes, Ethan.
100 squared is 10,000, right? Not 1,000.
Where are you looking?
Number 13. No, it's not on your thing. I'm just trying to figure out how I got mine wrong.
10 cubed is 1,000.
Yep. So 100 squared is 10,000. Because I put 100. I put 100x equals 100 squared.
Oh, no. The common base is 10.
Okay.
Just like you see how I have on the answer sheet. The common base is 10. And just a couple quick notes. 17 and 18, when you see a fraction, that's when you're going to have a negative exponent. When you see, let me see here. Does anyone need to ask me anything here? Towards the end of the week, I'll let you know tomorrow. It'll be either Thursday or Friday. Well, no, it'll be Thursday or Friday. You have one more thing to do for the third quarter. It'll be a 20-point quiz. This will be part of the quiz, right here, what you just got back, exponential equations. The other part of the quiz, I'm going to cover today. But I don't know, I don't know what you're getting right or wrong there. Yes? Yes, hurry up. Is everyone okay here? These are problems we had to get a common base. I mean, they're all similar, but you got to show me what you're doing. You don't just say x equals 4 and I don't know where it came from. Are you sure? Everyone's good. This is exponential equations. This stuff ain't going away either. All right. Now, take out the handout I gave you yesterday. Here, Chris, come and get this. Take out the study sheet I gave you yesterday. All right, your iPads, just set them aside right now. Just set them aside. You don't need them right now. Just get your notebook out. All right, now this is kind of big what I'm going to go through today. Okay, turn it on the back of the study sheet from yesterday. Here's what I'm going to show you today. And there's a lot of different situations, so I'm going to hit all the different things you can see. Okay, are you on the back of the study sheet? Look what it says back there. Your iPads you don't need right now, so just get them. Don't worry about them. A logarithmic equation is an equation with a logarithm in at least one term. You see log somewhere in the equation, you got a logarithmic equation. Now, what's the one thing I kept repeating yesterday? What does a logarithm stand for? I mean, I kept repeating it because it's important. Jimmy, it's an exponent. It's an exponent, it's an exponent. Now, to solve a logarithmic equation of the form, now look up here. I wrote it on the board. It's on your study sheet. To solve an equation that looks like that, it's going to say the log of something to a certain base equals that. Now, I'm just using a B, an A, and a K. I'm just putting letters there. First, you must write it in exponential form. Now, do you remember? Now, this is what you guys did in class yesterday. What does this mean in exponential form? You guys did this in class really fast. You turned the papers in. You got them all done in class. You can't forget this. If This is log form. What does this mean in exponential form? Come on, I just did this yesterday. Equal.
A to the K equals B.
Okay, there's the base, raised to that, equals this. Okay, now, everybody, go in your notebook. This is Tuesday, March 21st. Now let's do this first. Look up here. Leave a little bit of space underneath this. Write down A and B, leave space, and then write down C and D. Go ahead. I'm gonna take this in phases today. Please, this is big what I'm covering today. It's gonna carry you through stuff later in the week. So pay attention here. Write down A and B, leave a little bit of space underneath, and then write down C and D. Hey, John, could you close that back door? The directions are simply going to say, solve each equation for x. Now watch this. There's 3 different things that can happen up here. Now, you see all those problems on the board? They all look like this, right? They all look like this. Sometimes the variable is going to be there. Sometimes the variable is going to be there. Sometimes the variable is going to be there. That's what I'm about to show you. Now, you see A and B? See where the variable is? It's in this B position. Do you see that? See the variable? See the variable? Convert to exponential form. Tell me what to write. These are going to be the easiest kind. Convert this to exponential form. How?
4 to the negative 2 equals x.
Convert this to exponential form. You're going to start every problem exactly the same way. You're going to convert to exponential form first. What's this mean, exponential form? Come on, just use what's there. Come on, that's what we did yesterday. Wake up, you guys. Come on. This has got to stop, I'm telling you. You want me to change how I do the class? I will. If I were you, I wouldn't do that. A little bit more cooperation here, please. Adam.
1/2 to the second equals 3 equals 1.
Now, you know what you got to do to finish? Find x. Give me a break. When the variable is in the B position, it's the easiest to do. Because what is 4 to the negative second? That's your answer. That one's done. All the stuff on exponents I did the last 2 weeks, it's not going away. You still got to know how to work with them. Wow. Somebody, what's 4 to the negative second equal? What's the answer to that? Andrew.
Negative 16.
No. Andrew. Careless. 4 to the negative second means it goes down to the bottom, right? Right? So what's it equal? 1/16, right? All right, that's done. What's 1/2 squared? Rob? 1. No, it's not. Rob, what's 1/2 times itself? It's not 1. Ooh, you're freaking me out. It's 1/2 times itself. 1/4. 1/4 equals 3x plus 1. Are you kidding me? Whenever I say that, it means it's super easy to finish. How are you going to solve that for x? Oh my gosh. Guys, this is a very simple linear equation. Just solve it for x. What do you want to do here? You got 2 ways to do this. Do you like fractions? Nah, a number of you don't. I'll answer for you. All right? So if you wanted to, could you clear all the fractions out of that if you wanted to? Could one of you please tell me how you do that? David. You times everything by 4. Is that a legal step? Of course it is. Tell me what to write down if you multiply everything by 4. I'm just wiping the fraction out of here. All right, you guys are gonna play it this way, huh? Doubts? Multiply everything by 4.
1 equals 12x plus 4.
Variables left, constants right. Variables left give negative 12x. Constants right gives 3. So, go ahead, finish that. What's x? Max. What was that?
Would be, oh, it'd be, excuse me, 1, 4. Would it be negative 1, 4?
What?
Or positive?
What? Haven't done this in a while. I haven't done this since freshman year. People used to think I was deaf freshman year. Kid would give me an answer, I keep saying what? Then the kid would start yelling at me because he thought I didn't hear him. He'd give you the same answer. What's the answer again?
1, 4.
What? This is great. I haven't done this in a while. Let's see how long it takes. I had a kid one year, no lie. Some 9th grader, I don't remember who the hell he was. I kept saying what? I must have asked what 20 times in a row before the kid realized what was going on. He thought I was crazy. Bloomstein? Shh. This is fun. Not for you, but
No.
whatever. Yes.
I don't know why I'm blanking.
Baby stuff.
Yeah.
I'm making you feel good.
Oh, yeah.
Sorry.
I don't know why I'm blanking.
You're killing me, Max.
Gonna have to take the L on this one.
You're
You said it right the first time.
I didn't hear it. Won't be defending him if he said it wrong.
He did, he did.
Hey!
He did say it, yeah, he did say it.
Oh, sorry. I don't know what I heard. Okay, then what's the answer?
Whatever I said the first time.
Go ahead. Give it to me again then if you said it.
One of the
Don't look at him.
Um,
Oh, my Lord.
I said that. Yes, I did. I said that. Shut up.
Okay, now, when the letter's in this position, you just change the exponential form and go to your answer. Now, look at this. Somebody converts.
Got recording.
Well, Ian will be entertained by that then. Convert this to exponential form. Dave,
3 to the x power equals 27.
somebody convert this to exponential form. Come on, just like you've been doing, convert that to exponential form. Brandon.
3 to the x equals 3.
Whoa, 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 whoa.
Oh wow, I was on C, my bad. Wait, are you on B right now?
Yeah.
I'm on a whole nother.
Go ahead. 49 to
X,
the x equals,
this 7.
well, cube root of 7 for now. Now, look. Look where the variable is. Where is it? It's in the exponent. That's the homework I just gave you back. When the variable's in the exponent, this is the homework I just gave you back. These are the ones where you have to, when the variable is in the exponent, like these are the ones where you have to get, this is the homework I just gave you back. You were just checking the answers 10 minutes ago. Andrew, common base. What's obviously, this one's coming out pretty quick. 3 to the x equals, Mike,
3 cubed.
3 cubed, and then equate the exponents, and x is 3. Now, there's a radical there. You can't leave that radical there. What's the cube root of 7 mean with an exponent? Come on, this is all stuff I've taught you. What's the cube root of 7 mean with an exponent? Chris?
1/3.
7 to the 1/3, right? Right? Joe, stop. Oh, man. Okay, you gotta get a common base. What are you, a frickin' seal back there? Balance it on your nose? Jesus. What's the common base here? Tim!
7.
So what are you gonna do with the 49?
7 to the 2x.
7 squared to the x will make 7 to the 2x equals 7 to the 1/3. So how do you finish that one? Tim?
X equals,
No, equate the exponents first.
2x equals.
2x equals 1/3. Now guys, don't screw that up. What's x? If 2x equals 1/3, what's x? Be careful. I believe how many people screw that up. If 2x equals 1/3, finish it. No.
1/6.
Yes. Dividing by 2 means to times by 1/2, right? So this is x equals 1/6. Okay, now look what I've done so far. I showed you when the variable was in this position. I showed you when the variable was in the k position. All right, now write down problem E and F. Go ahead. Write down problem E and F. Write down problem E and F. Look where the variable is. It's in the base position now. Somebody, convert. Your first step's always the same. Convert to exponential form. Convert. Wetzel.
X squared equals 3.
Convert.
Me again.
Yes.
X cubed equals 12.
Now, look, I mean, wow, come on here. When you're, if you have x squared equals a number, what do you do to both sides to get the answer? You've been doing it all the time in trig. If you have a variable squared is equal to a number, what do you do to both sides to get the answer? You've done it so many times, you know, when we were doing trig stuff. Chris?
Find the square root.
Take the square root on both sides, right? If you have something cubed equals a number, what do you think you would do to both sides? Take the, come on, common sense. If you have x cubed equals a number, how would you get to x? What would you take on each side?
Cube root.
The cube root. What if you had x to the 4th equals a number? The 4th root, etc., etc., etc. What's x? I got that one's easy. If x squared equals 3, what's x? Andrew? Radical 3. If x cubed equals 12, what's x? Come on, don't let it bother you. If x cubed equals 12, what's x? How would you write it? X equals, just do the cube root on both sides. 12 is not a perfect cube, right? So all you can write is, Rob, the cube root of 12. You see that? Can you reduce the cube? Does 12 have any factors that are perfect cubes? That's the answer. Now, if that was cube root of 8, of course you would say equals 2. All right, write this down. X to the 3/4 equals 8, and right next to it, x plus 3 to the 4/3 equals 16. Now, I have a few more things to show you here. Okay, if I told you to solve those, let's see how observant you are up here on the board. If you have a fractional exponent equals a number, what do you think you would do to each side? Let me ask. If I said solve this for x, what do you think would be a real smart thing to do on both sides? Does anyone know? Howard?
Could you set each side to the power of the denominator to get rid of the fraction?
Explain yourself.
So if you set x to the 3/4 to the 4th power and 8 to the 4th power.
Take that one step further.
uh,
Here. How could I go from this to just x? What would I have to raise that side to so it would just be an x, which is what you're looking for? You only did part of it. What would you have to raise? What would you have to raise each side to get this just to be an x? Come on, use some common sense here.
If you did it by the reciprocal?
Yes. Watch. Raise each side to the reciprocal power. Look what I just did. Make sure you're getting this. See this one here? Raise each side to the reciprocal power. So when you have a fractional exponent, this is two different problems here. Raise each side to the reciprocal. Now, what's x to the 3/4 to the 4/3? Just x, right? Right? Power to power. What's 8 to the 4/3? My God, I taught you how to do that. What's 8 to the 4/3? You forgot already? The denominator's the root, right? And the numerator's the power. So what's 8 to the 4/3? Oh, boys, you can't forget this stuff. This was just from the last test you took. Noah.
16.
Isn't this the cube root of 8, which is 2? Raised to the 4th? You're done. Look how fast that was. One step. Raise to the reciprocal power. What's x plus 3 to the 4/3 raised to the 3/4? It's just, somebody, it's just, what? Alex. X plus 3. What's 16 to the 3/4?
Faculty, if you are aware the bell did not ring earlier, they're incorrect. So please do not hit it again until you are corrected.
What's 16 to the 3/4? What's the 4th root of 16? It's a perfect root, isn't it? Ethan.
2.
So the 4th root of 16 is 2, cubed is 8. So if x plus 3 equals 8, well, that's going to be pretty easy. What's x? Just solve for x. Okay. 5. So when you have a fractional exponent, now in about 10 minutes, when you take a picture of that, not yet, see those 5? It's all raised to the reciprocal power. All right, last things. This one, now, watch what's going to happen here. And this one.
Mr. Kennedy,
Yes,
you want me to open the door and tell him to shut up?
Joe, don't worry about that. They're going to be in their room shortly. Thanks for your offer, Joe.
Fight.
All right, write those two down. Give me the first line of work. You start every one of these the same way. What's the first step every time? No matter what I give you, what's the first step? It's never changing. I did it the first thing in every one of them. Howard.
Set it to exponential form.
Convert it to exponential form. So go ahead, give me this. Ethan.
X to the negative second equals 3.
What's this? Convert it, exponential form. Rob.
X to the negative 4.
Pay attention here. What do you think I want you to do to that? Because it's a variable to a negative exponent. What do you think I'm going to tell you to do first? What did we always do when there was a variable to a negative exponent? Now that was a hint. What did we always do when you had a variable to a negative power? Well, we did it every time. Max. What means the same as x to the negative second, but no negative power? Noah?
1 over X.
Okay, write that down. Watch this. What's x to the negative 4th with no negative power? Joe?
1 over X to the 4th.
Now look at both of these because they're very similar. That's over 1, right? This is a freshman algebra question. 1 fraction equal to 1 fraction. 1 fraction equal to 1 fraction. What are you allowed, those are called proportions, by the way. What are you allowed to do when you have 1 fraction equal to 1 fraction? This is a freshman algebra question. What are you allowed to do? Because I know as soon as you hear it, you're going to go, oh yeah. When you have 1 fraction equal to 1 fraction, what did we always do to solve? and you have one fraction equal to one fraction, we always add them. Cross multiply, right? Here, cross multiply here. Tell me with the right. Look, cross multiply. Go ahead, cross multiply. This must equal that, right? Go ahead. Howard.
1 equals 3x squared.
Well, let's put the variable plug first.
3x
3x squared equals 1. Okay, what are you gonna do with the 3? We're gonna solve, so x squared equals, this is all basic algebra now. Ethan? 1/3. So what are you gonna do to both sides? Actually, one of you had a chance to correct me on something earlier, and you didn't. Let me go back to this real quick. What's the mistake here? There's something not here. I just noticed it. See, you all let that go. Zona,
Plus or minus.
right? That should be plus or minus there. So when you take the square root here, this is gonna be plus or minus. Okay, go ahead. It's the square root of 1/3. Remember, no radicals on the bottom. Did that in trig all the time. Go ahead, take the square root on both sides. Plus or minus. No radicals on the bottom. Ethan.
Radical 3/3.
Radical 3/3. And here, cross multiply. X to the 4th equals 16. Remember I said if you have x squared equals a number, it's a square root. If you have x cubed, it's a number, it's a cube root. If you have x to the 4th equals a number, it would be a 4th root. What's the answer for x? If x to the 4th equals 16. John?
2.
Not quite. Why? Because it's even. If it's an even root, it's always plus or minus. Plus or minus 2. Now look, I covered all the bases here. Question?
If it's, if that, since that's cube root of 12, we don't have to put plus or minus?
No,
It's odd?
never, because it's odd. That's right. Odd roots is it's only one answer. Even ones is plus or minus. All right, now take your iPad out. Let me